Alright, time for another dryphysics.com video presentation. Where the hell am I? I should be in the show somewhere. There. Okay. That's a little better. Alright, so I'm going to do another video response to this Parth guy, one of his videos, and on energy. Yeah, it's just really bad. Anyway, but first, I just thought I would point out that I have been doing live videos, and I thought they would just show up in my regular videos index, and they don't. So you actually have to click on this stupid live tab to see that there's live videos. So for subscribers, it's not really a problem. I guess you still have the live video show up in the subscription list, but it is sort of irritating, that they're in different categories when they're both, basically the same content, close enough. They should be in one tab. I mean, it's just kind of silly. They should just mark the live videos with some other marking. Anyway, if anybody knows how to force the live videos to go into the regular video tab, I would appreciate it, because it'd probably be better that way. But anyway, it doesn't really matter. Just pointing it out for those who care. So it's just part of getting to some point where I would like to do some whatever interview conversation videos, but have to find somebody willing to participate and all that kind of crap. And also, I guess the interactive part does work out a little bit. Doesn't hurt to talk about various subjects in a video and all that shit. So I did do a video response to his Parth guy's video on diffraction. So that's in the live section. So it's not in the video section. But whatever. Just complicate something that shouldn't be complicated. I don't know how the search works. So I don't know if the search searches the live video. So I don't know. Yeah, the whole thing is just a little bit not quite right. Alright, anyway, so we'll get back to the other video. Alright, so leave us begin.
Hey everyone, Parth here, and in this video I want to talk to you about energy. It's a pretty central concept in the world of physics. For example, we talk about things like kinetic energy or potential energy or the law of conservation of energy.
Yeah, and it would be okay if you left those as in the context of energy as being one thing. That is, everything is energy. Anything that you notice or any change or anything is all energy. So energy causes matter to move, and then when matter's moving, it has energy. And that's pretty much what needs to be stated, I think, as one of the axioms of energy. And what you're conserving is the movement. So something like this, the energy can be broken, this movement in one direction can be broken into a bunch of little tiny molecules moving in all kinds of directions, and that would be heat. It at least be a kind of heat. It's just really about, that's what energy is the source of it, the mechanism that it is little stuff moving, and the big stuff contains little stuff. So the big stuff can have a bunch of movement inside of it in terms of heat, have energy in the form of heat, or it can have energy because all the stuff's moving in one direction, and we can call that energy. And then we can understand that when it is all moving in one direction, it's really easy to subtract something called work. So work is just something's energy that we make do what we want to do because it's doing the one direction thing. Can't do anything if the energy is going in all directions. There's nothing you can do with it. You have to make it go in one direction to do something with it, and that's sort of another principle. So there is no separate thing like work is a form of energy. Now, work is the same energy as heat. It all turns into heat eventually. All work going in one direction eventually ends up being energy in all directions. Again, that's what it all turns back into. All energy is really heat, and when heat's moving in one direction, we call it energy. Something like that is closer to the truth, in my opinion.
But what exactly is energy? Before we answer that question, it's worth me noting that we will be looking at the physics definition of the word energy.
That's not all. You're not doing that either, because the physics definition of energy is convoluted mush. It's momentum and it's kinetic energy theory, and you have a bunch of statements regarding how energy is derived. They're just plainly wrong. So I could just not play the video and just point out all of those, but we'll play a little more.
Used in day-to-day life quite a lot to mean a few different things, and those meanings aren't wrong. They're just not the physics version, which is what we'll be looking at.
So he really doesn't look at any physics. There's no physics version versus day-to-day life version. We interact with things that are hot and cold, and we interact with, where we have more energy and we lose our energy. We interact with friction, and it's really not hard to figure out that friction is taking your energy away. It's blending your condition with the thing you're touching. I touch something, I'm blending my condition with it.
Now, different scientists will define the term energy in a few different ways, and we'll see why that is in a second. But the first and
there's no good reason for why that is. So that's also a point that needs to be made. And again, there is really no different kinds of energy. The energy is like a Planck thing. It's a unit. It's a quantum of energy, a corpuscle of energy, and all you're saying is that in some forms those corpuscles can be organized, and we can exploit that, or they're not organized and there's nothing to be exploited.
Foremost thing that I want to mention here is that energy is a very useful mathematical idea. It is
well, again, it's just kind of silly. It's it's physics, period. It's the first word of physics is energy. Energy is why there is physics. It's why there's time. It's why it's movement. It's movement of momentum, things with mass, things with a capacity to affect another thing. It's things interacting with things. That's physics. And energy is how they interact. Period.
It's a mathematical concept that helps us predict how the universe around us will behave.
All right, so more of this predict word. You don't predict very well, frankly, and you just distort and pervert the viewpoint to make your predictions mean something, and they don't. They're silly. You predict that it takes 4 times more gas to go twice as fast. It doesn't. Okay, so what's the use of your predictions? You don't predict accurately. You just sit there and contrive special circumstances where it turns out your way, and then all the other circumstances are ignored. It's like the double slit experiment. Well, we only predict the case of the infinitesimally small slit. We don't predict all the other cases. The 99.99% of slit experiments we don't bother with.
Say, for example, we're studying something like a car moving along a road.
Right. First you have to figure out whether the car has an engine and is actually making itself move, or where does it get it? It's going down a hill. There's lots of different ways it's getting its capacity to move. And the question is it using friction to gain velocity, or is it losing velocity to friction? Is it accelerating, or is it decelerating because it's losing its energy to the ground, because it has contact with it, and it's going to share its heat, so to speak, with the ground. The ground has 0 in this case. The car has plus, and the car is going to basically give away a portion of its, and the road's going to is going to absorb it, and that's going to continue until they're both equal. And because the ground is gigantically huge, the planet Earth, guess what? The car is going to go to 0.
You can assign it a particular amount of energy based on the kinetic energy equation,
which is a pile of made-up crap, okay? 350-year-old made-up religious theory that has nothing to do with reality. So Galileo, Descartes, and Newton all thought energy was just MV. A silly person, okay? Somewhat a disreputable physicist, let's just argue. He did die in disrepute, okay? Nobody showed up at his funeral. So Newton was buried as a god. Leibniz, his worst enemy in life, who came up with this crappy theory, was buried a nobody. And then in 1735 or whatever, this dead theory was dug up. They did some silly clay experiments and fooled everybody into thinking this crap was real. A bunch of silly hippie types, intellectuals, propagandized for the little living force, it was called. The living force. It's baby, juvenile, trivially stupid physics. Okay, it doesn't have anything to do with reality. It's made up babble.
This happens to be a carefully calculated equation.
No, it has to be a completely contrived calculation, one where you just ignore logic and reinforce it with silly circular mathematics. You create other equations that are just as silly, like, the gravitational one, right? mgh. It should be mgt. And then you do the work equation. Force times distance. Well, it should be, it's force times time. How long are you applying a force matters. How far it's moving or some other kind of crap, that's not a definition of its force. That's not a way of measuring its force. Because frankly, in space, it'll move forever.
That will allow us to predict what will happen to the car and its surroundings if something were to change.
Whatever. So there's nothing changing, but yes, okay. So yes, clearly there's change in just the fact that you're losing some energy to all of the different little friction sources. And I guess the change would what be? A brick wall? Well, yes, if you crash the car into a brick wall, you'll find that your 1/2 mv squared doesn't show up anywhere. If I crash a car at 50 miles an hour, it crashes this much. If I crash it at 100 miles an hour, it crashes twice as much, not 4 times as much. So again, you're illustrating this silly equation, and you really have zero evidence for it. I mean, they really haven't shown up with any other experiment except the 1735 silly let's draw up round balls into clay experiment. So beyond the round balls into clay experiment, you have no other experimental evidence demonstrating that nonsense to be anything close to the truth. And it's the most important subject in physics, energy. And you have a preposterously silly, unevidenced piece of mush as your foundation. That doesn't make any sense. Squared velocity. There's no geometry to velocity. It's a completely one-dimensional event. There's no such thing as measuring one thing's velocity, okay, in multiple directions, except for, I could explain, in the case of an electron.
For example, if the car were to slow down, if its speed were to decrease, then its kinetic energy would decrease as well.
And so would its momentum, yes. But again, it's just garbage in, garbage out. Yes, if you have a garbage fake perception of its energy definition, then yes, you do something and now you can have a new fake definition of energy.
This exact same amount of energy would be transferred to the surroundings of
that. Doesn't happen, so that's the big lie, because it can be demonstrated quite convincingly and proved quite convincingly that every time I have contact between two different massed objects with the same momentum, I'm transferring the momentum completely from one to the other, I'll either make free energy or I'll lose insane amounts of energy. If I fire a bullet into a gun, okay, somehow the gun leaves with 2 joules of energy and the bullet went in with 2,000 joules. That's your theory, and it's mush.
The car in different forms. One example of this is the energy being transferred.
So there's no different forms really. The real universe, the Plancke stuff, the little tiny bits, there's no different forms of energy. There's just the forces that move matter, and that's it. And the force has all the energy, and the matter just goes where the force tells it to.
Transferred to the road through the tires of the car, both of which end up heating up. In other words, we could potentially measure the temperature change of the road. We could see that the temperature increases.
Yes, the energy always has to go somewhere, and temperature, a rise in temperature, or an increase in heat is just an example of energy going in one direction being converted into energy going in all kinds of directions, and therefore not being very useful.
The energy change that causes...
obviously it's just not very useful to get any work done if something's doing both things. If two people are having a tug of war, they're doing lots and lots of work and nothing's changing, right? The little flag isn't going anywhere. Lots of work wasted.
The road to heat up originally came from the energy change of the car. And so the important idea is that we can assign...
So let's understand that, yes, it came from the car. That's right. The energy came from the car. The energy has to be conserved. The car has it. It's moving. You contact with another substance. The other substance takes some of the energy. You can't create energy that way. You can't lose energy that way. You're just transferring the energy from one big thing moving in one direction into little things moving lots of directions.
Different energy values to different parts of the system that we happen to be studying, the stuff that we happen to be studying. But this whole idea about assigning energy values does not mean that we can assign absolutely any random energy value to anything in our system.
Right, but we can. We can assign one universal energy value to what Einstein would have called the quanta of energy or momentum. And we could understand that you just add up the quanta, and everything is quantized, and it comes in full amounts of a hit, a no-hit. And it absolutely... Field theory essentially is conceding that point.
No, the energy values that we assign are based on some very carefully calculated mathematics.
Okay, it's obviously not carefully calculated because it's so stupid and wrong. Okay, I mean, the fact is that you drop something in gravity, that you drop it 4 times the height to get twice the velocity. Well, you got twice the velocity in only twice the amount of time. Okay, so it doesn't mean that you've got 4 times the energy. Because all you have is twice the velocity. And it only took twice the time. You're only in the gravity to gaining energy from the gravity for twice as long. How can you gain 4 times as much energy if you're only collecting the energy twice the amount of time? So again, it's so obviously stupid. Okay, mathematics. It's not very careful. It's very sloppy.
And the reason for that is that everything we see around us seems to behave in a...
Alright, so this is the part where you're just like, what the fuck? No, everything around me seems to behave exactly the opposite of your silly theory, okay? Your silly theory says if I use an 8-pound bowling ball and I throw it twice as fast as I throw a 16-pound ball, I'll knock down twice as many pins because I have twice as much joules of energy that I'm smashing the pins with. Yet no professional bowler uses one. By your theory, I'm better off knocking down a building by shooting a bunch of bullets at it. I should never waste my energy by swinging some heavy 10-ton wrecking ball. That would be the worst way to do it. It's such a waste of energy. I mean, there's nothing 4 times more gas to go twice as fast. We know the rocket going into space. We know I don't have to spend the same amount of fuel, per foot. I can insanely increase my per foot to fuel to foot mileage by increasing how far I go. That is how fast I lift off. The faster I can lift off, the much further I'll go at a much more efficiency. So per fuel, my fuel economy gets insanely better. So if I shoot for, escaping Earth's gravity, I'll be paying, 0.000001 cent for the energy. But if I just shoot for 1 foot, then I'm paying $58 per foot. Those are the facts. So there's nothing about our experience that has anything to do with your silly theories.
Very particular way. It seems to behave as if the total energy must always be the same.
Well, it's not just that it has to seem that way, it's just absolutely no reason for the default to be any other way. The whole idea that somehow you could make motion disappear is kind of fallacious on its face. And yes, the only time it looks a little bit like that is if I bang 2 things into each other perfectly and nothing moves. But the argument would be is you're just not seeing the movement because it's there. And they even figured that out 350 years ago. They could figure out that, it's always there somewhere. You're just converting energy that's really easy to see into energy that's not easy to see. That's the simple statement. There's energy that's really easy to see, and then there's energy that's not easy to see.
it must remain constant. As a basic example, let's imagine a snooker ball or a pool ball moving along a table and it has an energy of 0.003 joules. But then something changes. This ball collides.
So if they did this experiment with odd size masses, well then all of a sudden their kinetic energy theory loses energy all over the place and gains energy all over the place. It makes a mess. It can't get the right answer.
Collides with another ball placed here. At this point, lots of energy transfers occur. So for example, the first ball loses kinetic energy.
It decelerates, that's right. It's going to mix its heat, so to speak, its directional heat, okay, where the other ball doesn't have any directional heat in that direction, or it doesn't have any opposing. It doesn't have any in either direction. So it has the two of them have a differential, a relative differential. And now that relative differential is going to be mixed between the two. And the fact is if they're the same mass, the mixture will basically be as the energy will just slide right into the other ball. It'll just keep going in the direction it's going, and it'll just move from one to the other. One will decelerate at exactly the same rate as the other one accelerates, and therefore there'll be no blowback, there'll be no reflections, there'll be no incompatibility. But if I change the mass of the balls, no such luck. You can't just push the energy in because the deceleration of one won't match the acceleration of the other. But I can put them on a lever. I can put a little lever right here, and then I can do that experiment. I can physically create, okay, a 5-ton train going 10 miles an hour by plowing a 10-ton train going 5 miles an hour into the other side of the lever. And I can make, by your theory that you've well tested and you've carefully mathematically done and all this crap, by your theory I just made free energy.
Because it was moving at a particular speed before and it's now moving slower, so its kinetic energy is lower than it was before.
I don't know why he has them both going off in the same direction. It's not the outcome you're usually going to get.
In a similar way, the second ball actually gains kinetic energy as it speeds up. And also, there is some energy that goes into the clicking sound that we hear when the balls collide, as well as this.
So it's a pretty bad example because he doesn't really point out the velocity change. He just says energy equals 0.0014 joules. I don't know. This one has 001. This one has 0014. Well, whatever. It doesn't make much sense.
There is some increase in temperature of both the balls and the table due to friction, and so
yes,
on.
there are tiny amounts of losses, and the more, if I do this as a Newton's cradle instead of a snooker table, then all I have is a little bit of air resistance, so I can get rid of so much of the friction, and we can see the conservation of energy in the fact that it can oscillate 100 times.
And so forth. But if we account for all of the energy changes and we look at the total energy of the system before anything happened and after something happened, the total energy...
That's right. The total energy is just going to be the work, what we counted and we could see, plus the friction, the losses. The places where the invisible energy seeped out of the objects.
Energy seems to be exactly the same. It's constant. This idea is known as the law of conservation of energy.
And you obviously don't believe in it or consider it to be of any meaning whatsoever. So if I put if I have a gun that weighs 3 pounds, and I actually put I put a 3-pound bullet inside the gun, and I fire the gun, I get a total of maybe 8 joules. But if I take the gun and I put a bullet in that's 1,000 times lighter, I'll get 2,008 joules. That's your conservation law at work. Nonsense.
It seems like the universe behaves in such a way that the total energy of a system is always constant. And crucially, this allows us to make predictions about how certain things in the universe, or the whole universe...
And the predictions are garbage, and I can show a Professor Lewin experiment where, yeah, something ludicrous happens. I mean, I have 100, joules of energy go in, let's say. Let's just use momentum. So I have a mass and velocity of 100. All right, and somehow I have coming out of the experiment 133 going this way and 33 going that way. So somehow I magically create a bunch of extra energy, 66 altogether. 33 extra that way momentums and 33 extra that way. That's your physics, okay? But I can show how the experiment's a fake, okay? Obviously a fake, with obvious defects. It can be visually seen, all right? And that it's just contrived to support the mathematics. It's not contrived to support what is all around us as a rational truth, which is if I push twice as hard, something's going to go twice as fast. And you're defending a theory where, no, I push twice as hard and it only goes 1.4 as fast.
For that matter, should behave in given scenarios. Now, many of you will be familiar with this law of conservation of energy. It's something that's taught very commonly in high school physics.
It's a concept. Okay, whether it's a law or not, it's a concept of understanding that, all right, if I bang something into something, something else has to move, okay, and I really just have to account for it like money. And there's no part of the system where the money is burned, and there's no part of the system where the money is created, so I can understand that it's just cycling through. And again, this is something Descartes, in 1610 or something, whatever the hell it was, figured out. So, and you didn't do anything to improve on what his work, obviously.
And it seems to be a huge reason as to why the idea of energy is useful in the first place. Many physicists don't actually care what energy is.
Oh, I mean, it's just amazing. Yeah, well, that's your whole problem. You've turned everything into some abstraction, okay? And it's not abstract in any way. It's so mechanical. It's so fundamental. The forces have the capacity to exchange momentum. Gravity causes momentum. It causes objects to move. Okay, light pushes on objects. It causes things to move. Electrons move. Electricity, magnetism cause things to move. The force obviously injects momentum. The forces, therefore, must be momentum. And that's what Newton basically said. He basically said force equals momentum. You can interchange a force with a piece of matter with momentum. They're interchangeable. You want to give the object twice as much momentum, just hit it with twice as much force.
Some say that it's just a mathematical concept. Others say that it's a property that objects have.
Just imagine how this would have been so simple if the Leibniz thing never happened. Just imagine the universe is just something so simple as mv. And that all you're saying is I can convert energy from gigantic masses with very tiny velocity, very tiny velocities, to tiny masses with very big velocities. It makes perfect sense. It's so rational and complete. And now they've broken it into this completely incomplete theory, and it's a foundation to all their particle physics. All their particle physics is dependent on this wrong equation, these artificial energy levels. So everything they say about how much an electron weighs, or how much a quark weighs, or what the spin is, or all that, it's all based on this wrong understanding of energy. They think because something goes twice as fast, it has 4 times the energy. And it's absolute nonsense. And just imagine what they're doing to things that are going 8 times as fast or 100 times as fast. They're creating millions of watts of free energy.
I will agree that the important thing about energy is how it changes. And specifically what I mean by that is how it transfers from one place to another.
Yes, it's so at least you didn't say one form to another, but all it's doing is though it changes from one place to another, but it has to be converted into the currency that object can absorb. The Earth can't absorb 70 miles an hour. I could crash something into the Earth won't absorb 70 miles an hour. Can't make the whole Earth move. So what happens? Pieces of the Earth will move at all kinds of different velocities based on their size. So if I hit a bowling pin with a ball going twice as fast, the pin will leave with twice as much energy as it'll leave if I hit it with a 16-pound ball. So even the 16-pound ball has this, momentum, it can't exchange its momentum as readily as the 8-pound ball going twice as fast. That's one of the rules. So faster objects can dispose of their energy more quickly. They don't have more of it, but they can dispose of it very quickly.
And what impact this has on the system we're studying. The law of conservation of energy seems to hold really well in experiments that we've done so far.
Okay, so it's just, show me. Show me any experiment where it holds, where you have an exchange between things of an even mass. And I'll show you how your experiment is bullshit. Show me. You're taking 4 times more fuel to go twice as fast. Show me. Show me the bullet doing more damage to the building than the wrecking ball.
And as a result of this, we can use it to make predictions about how our system should behave. If we can measure something that allows us to work out how energy has changed in one part of a system, then we can predict how another part of the system should behave, for example. Now,
whatever. Again, it's just follow the little tiny bouncing balls. And all the big object, the only difference between the energy in the big thing and the energy in the gravity is the motion, the direction. It's a giveaway. It's probably not the best example because obviously gravity is quite directional. So the direction is kind of a consistency about gravity. It's the stuff moving in the same direction. But what you're doing in most cases is finding some way to convert chaos, energy going in all kinds of directions, and putting them through some kind of matter that forces the energy, okay, through reflections and deflections into all having the same motion. And that's the stuff we see.
I just mentioned that sometimes physicists treat energy as a property that things have. We often do this for simplicity.
Yes, that would be the best way to think of it. It's something it possesses. Energy is what you possess, the force. Gravity affects you. It's a force. You absorb the force. You hit the ground. The force is released. It is that simple. You're a carrier. You carry force when you have velocity. It means something gave it to you.
And because it makes intuitive sense to us. For example, if a car is moving, we say that it has kinetic energy, rather than just being a mathematical quantity that we assigned to that car.
Well, whatever. So, and again, I can make the relativity argument that you can know, I can have a brick wall, and I can have a car, and even though it's just a relative experiment, I can prove which one is actually moving by crashing the car into the wall.
Or if we have something like a ball raised above the surface of the Earth, we often say that it has gravitational potential energy.
When little things hit big things, the universe looks different than when a big thing hits a little thing. And that fact proves that relativity is irrelevant. All right, so here's the MGH. So what can I say? No, it's MGT. MGH will get you the wrong answer. Something going twice as fast, dropped from 4 times the height, will not hit the scale with 4 times the weight. So here's another argument. It's twice the velocity, it's twice the time, and when it hits the scale, it's only going to be twice the weight. So how can you claim it has 4 times the energy? 4 times the height. I'll increase the height 4 times. I drop it from this height, it weighs whatever, that much. No, we'll go that much. I drop it from 4 times higher, right? I drop from here. Drop 4 times higher, it only is twice the weight. So how can you believe this? And this is your carefully constructed physics. It's an absolute fact. I'm just saying I've done the experiment, okay? I already knew the answer before I did it because it's so much a part of our life, scales and levers. But that's it, okay? 4 times the height, only twice the weight. How can that be 4 times the energy? How can something that only weighs twice as much have 4 times the energy?
By virtue of being in the gravitational field of the Earth. And in most scenarios, this idea that an object has energy works perfectly fine.
Yes, it does. And the idea that you need to be in the force to collect energy from the force. So again, if I have a gravitational body, and I go zooming past it real fast, it doesn't affect me because I'm not in it very long. So it doesn't matter the distance. What matters is how long am I in the force. The time the force is acting on me is how I collect energy from the force. It has to be contacting me for me to collect it. And if I zoom through it, if I zoom through a gravitational differential, it'll affect me very, very little. And if I go really slow through it, and I'm in it a long time, yeah, I'll plow right into the planet. Those are the facts. 1/2 mv squared wasn't in the computer that landed the lunar module on the moon. 1/2 mv squared isn't true anywhere in space.
But unless we clarify what we mean by that, it's easy to fall into some common misconceptions. For example, it can be easy to imagine energy as some stuff, like...
Yes, it's stuff. Force is stuff. It all has momentum. You can pretend it's the non-existent, no mass stuff, whatever you want to do, but the fact is it has momentum. It imposes a momentum. There's no point in denying it that it has a mass. And the velocity is always the speed of light, which is the speed of force. All the forces move the same speed. That's why the whole thing can be quantized. You're just missing the whole point of quantum mechanics. You clearly don't understand Planck at all. Planck. Okay? I mean, the whole idea that, yes, the universe is made out of this little tiny quantum of force. And it makes light, and it makes magnetism, it makes electricity, it makes gravity.
A fluid, for example. And an object with lots of energy is filled with this energy fluid stuff, whereas an object...
Just say stuff. It doesn't have fluid. Why do you have to turn everything into some goopy fluid? Is this a biological response because you're a fluid, an organism full of fluid? You think everything runs on fluid? Just call it stuff. What's wrong with stuff? Or a bit.
With less energy isn't quite so filled with this stuff. And indeed, a long time ago, scientists thought of heat, a type of energy transfer, as a fluid.
Yeah, they thought of electricity as a fluid. So what? It doesn't mean that because they had an archaic idea that that whole concept of it being a real substance, that is, the forces are real, they're not fake, they're not bent geodesics, they're actual stuff moving. The light actually does travel from... it reflects off me, it goes through the lens, it goes to hit the frickin' electronics and moves electrons. It's real somethings that are doing that. It's not a nothing doing that. It's a something doing that. A something with momentum.
Turns out, though, that the word fluid has a very specific definition. Check out this video if you haven't seen it already.
No, I wouldn't. I'm not going to bother. Thank you very much.
And energy actually behaves quite differently to this. Therefore, I personally think it's more useful to think of energy as a mathematical quantity that we
He said a kind of stuff. Well, there. Simple. Good.
can assign to whatever we happen to be studying. And I find it very interesting, by the way, that our system, the thing...
Why make something so fundamental and something screaming, I'm here, I'm here? I mean, energy's screaming it at you. Force is saying, I can do it. I'm real. And you want to say, now we'll just treat it like some sort of mathematical abstraction.
we happen to be studying can be very, very small indeed, or can be as big as our whole universe.
Right, so the little tiny bits do all the real moving. So another joke here, I could just make as a joke, is if you really thought about this, you'd understand that the only universe is the one where these little dots are. Everything that happens in this bigger place has to happen in those little tiny dots universe first. Everything that happens, my finger doing this, the little tiny dots had to do it first. They're in control. The universe where the little dots are, the little electrons and protons, that's where all the action is. They make everything else. Everything else is an emergent property of their movement and function. But you don't even get that one right.
Now, I quickly wanted to mention that sometimes different types of energy, different kinds of energy that we're taught about, can...
Right, we're told about the different kinds, and we really should understand that no, it's really just stuff moving electrons and protons, and that's all there really is. So the force moves electrons and protons. The electrons and protons get into different configurations, and that means they're going to reflect a different kind of force field, because they're doing what the Earth does, and they're doing what we do. We're reflecting whatever hits us. We're creating equilibrium. between I don't collect energy. No. I collect it, hold it for a little tiny bit of time, and I spew it back out again. It leaves again. It doesn't stay here, okay? And everything's doing that. So whatever goes in eventually comes out.
Seem like a little bit of a...
Except for the original atoms and different things. Certain configurations, the energy went in, and it's been staying in there a very long time until we decide to make a nuclear bomb and release that stored energy.
Mathematical fudge. And for those of you that are not familiar with this term, what we mean by a fudge is basically a sort of...
a cheat, a shenanigan, a pile of crap. So the work equation, pile of crap. The MGH, pile of crap. Lots of 1/2 mv squared, pile of crap.
Quick fix or an improvisation or just something a little bit made up to make the maths make sense. For example, I often get asked...
Yeah, to get the formulas to agree with each other, you basically have to marry them into each other by breaking them all.
About potential energy and whether this is just a mathematical...
Well, whatever. Yeah, but potential energy is silly because in most cases you're not really talking about the energy it has yet. Potential energy just means, okay, the stream has energy. I have a boat. Am I going to say the boat has potential energy? Well, no, it doesn't have any energy until I put it in the fucking stream, okay? So without the stream, the boat has no energy. It's just stupid to say it has potential energy. No, it doesn't. Until I release it into the stream. I mean, these are simple logical arguments. So yes, most of the things we call potential energy are about a circumstance. It's not about the thing having any energy. It's about the fact that you have it right next to a stream and you're almost going to stick it in the stream. And so now it's going to be moving. I mean, it's that kind of simple where, you know, my finger has potential energy. Well, no, it only has energy if I put it in the stream and let the stream push it.
Fudge. Like with kinetic energy, things are kind of obvious. An object is moving...
Alright, so there's using the word kinetic as opposed to potential here. So he's not using the kinetic energy theory. Now he's talking about kinetic energy, which could include momentum. And so this is where they break all kinds of rational vocabulary. There's no point in having this term kinetic mean two different things. That is, kinetic means active energy, and then kinetic also means 1/2 mv squared. And, you know, that just doesn't work. You have to narrow your definitions better than this. Calling active energy kinetic energy isn't quite the same because your definition of kinetic energy is actually 1/2 mv squared, and it isn't mv, which is momentum, which most people consider to be kinetic energy versus potential energy. When somebody says it has kinetic energy, they're talking about its momentum in most cases.
And that movement is associated with some amount of energy. If an object speeds up, its kinetic energy increases. If it slows down, its kinetic energy decreases. But something like...
Yeah, but it doesn't do it. You can't prove that it's 4 times more energy. So again, more nonsense. I double the velocity, there's not 4 times more energy. So again, big lie.
A ball in the gravitational field has like stored energy that will allow something to happen later, like the ball falling to the ground. Or a stretch spring has stored energy again.
So those are two different examples, right? So in one case, you're going to dump it into a stream. In the other case, you're going to theoretically push magnets into each other and create a real potential for expansion. So in one case, you can really understand that you can see the storage, where gravity, you don't see the storage part because it's an active stream, and you can see that I'm just throwing the boat in the active stream. So they're really not... they really do show different ways, and one way is a lot more, you could say, the spring storing the energy. It actually is storing it, okay, where gravity isn't storing it, and it isn't releasing it.
And because the spring will eventually ping back, yeah, I can see why that feels like a little bit of a fudge. But firstly, this clearly illustrates the problem with thinking about potential energy as an amount of stored energy in the conventional sense.
It's always an amount of energy, either possessed by something or lacking possession. You're either under high pressure or you're under low pressure. It's all on a gradient somewhere, and there's no place to be but on the gradient somewhere.
And secondly, even if it feels like a mathematical fudge, It's important to note that potential energy works consistently across different systems.
So again, it's just they keep telling us about how the thing works when they can't show you a single piece of evidence demonstrating that it works. Credible evidence. Not a single piece. In 350 years, we have no credible evidence. The clay experiments can be easily debunked by anybody who understands something about geometry. If you understand why pointed arrows penetrate objects better than unpointed arrows, then you can understand why those experiments are crap. And that's all they have. So in 350 years, they have no experimental evidence demonstrating the existence of mv squared, or living force.
It tells us exactly
Vis visa, as it was called. The religious concept. God's energy.
what should happen when some amount of energy change occurs. For example, a ball with a mass of 1 kilogram.
So it's not a change, it's just an exchange. So this is a key word, key concept, should be pushed pretty hard. You never change energy, you just exchange energy. You exchange a condition. You can only exchange your hotness with something cold.
Placed about 10 meters above the surface of the Earth, when released, should accelerate down towards the surface of the Earth, and just before it hits the Earth's surface, it should have this speed. And it does.
Yes, it does, and it's only twice the speed, 4 times the height, twice the speed, twice the time, twice the weight. Obviously, MGH is incorrect. It's mg, time.
Consistent basis. It doesn't matter if it's a 1 kilogram ball or if it's something else, as long as we're using the correct values for the mass of the...
And you're not using the correct values for how much damage it will do to the ground. It will only do twice as much damage to the ground because it's only twice the pressure, it's only twice the weight. You're only doubling its weight. You're not quadrupling its weight. It can't have 4 times the energy because it doesn't have 4 times the weight. Car crashes are about weight. It's about giving a mass velocity, which is increasing its weight.
The object, the height above the surface of the Earth.
Weight is a measure of energy. Our mass has 0 weight, okay, unless it's moving in gravity. And we're moving sitting in the chair. And you can tell you're moving because you'd have to move for the Earth to push you back. The Earth couldn't keep pushing you back if you didn't move into the Earth. Duh.
We're maybe ignoring or even accounting for air resistance, and we know the strength of the gravitational field. We can consistently calculate the amount of potential.
You can consistently calculate a fake number that has nothing to do with reality. And that's all that is. 1/2 mv squared is not a real thing.
Energy it has and what impact losing this potential energy will have.
Right, it doesn't predict the correct impact. It just states it. It states it. Okay. It doesn't prove it, it doesn't show it. They'll never show you that 5-ton train going 10 miles an hour moving more matter, okay, giving more energy to matter, creating more heat, doing any of those things than the 10-ton train going 5 miles an hour.
On the object.
They have no experimental evidence defending the theory.
Okay, let me talk about another commonly used definition of energy. You may have heard that energy is, or is related to, the ability to do work. And work, in this case, is of course used in the physics sense.
Right, and again, the simple equation, they screwed up. Okay, it's not about how far something travels. It's about how much time you're being pushed by a force. That dictates how much work you can do. And also should be stated that this is such an incomplete statement because obviously, okay, you can be doing a lot of work in terms of friction and other things. So when they do this classically, they sit there and say, look how far it rolls when it's losing its energy to friction. And the friction is being controlled by gravity, which again is a constant force. and the distance, so it goes 4 times the distance, but only takes, again, twice as long. So it's only losing energy to the friction twice as long, not 4 times as long. This is the obvious stuff. So yeah, fake equation again. It's force times time will tell you energy. It doesn't tell you work. It tells you energy. Because clearly friction can be stealing at any point.
It's defined as the force applied to a particular object multiplied by the distance the object moves. Or at least that's the simplified version. We won't go into the detailed version here.
Yeah,
now, this is pretty reasonable.
Because it's nonsense. But if I did it in space, I'm going to get a clear, obvious answer. Okay, that the distance is always going to be proportional to the velocity. So I'm going to get the clear, rational answer that, yes, twice as fast, twice as much work. It's going to go twice as far. Something's going twice as fast in space, it only goes twice as far in any unit of time.
Try and work out what work actually is rather than just a product of force and distance, then we might see a wordy definition of...
Right, so the simple definition of work is energy that's moving in one direction. Heat moving in one direction is useful energy that we can make do work. And it's very hard to make scattered energy do work. It's very hard to do it efficiently.
Work, which is that it's the energy transferred to or from an object due to the application of a force. And so if our worded definitions define energy in...
So it's clearly not. That doesn't work. I mean, that doesn't explain it at all, because then friction becomes work, and then heat becomes work. And yes, it's all energy, but you're really missing the point. So the whole word work shouldn't even exist. Because in physics, they say, I do this. I hold this object up against gravity. Because it's not working... because it's not moving, there's no work being done. When obviously I'm doing a lot of work holding it up against gravity. I'm doing what the ground is doing all the time, pushing it back up. I'm doing lots of work. So clearly the physics definition of work is crap.
In terms of work and work in terms of energy, then this is a little bit of a circular argument. And if you don't have...
All of your arguments are a lot circular. They're not a little bit circular. They're insanely circular. They're invisible man-silly stories that you tell and pretend that they're smart or clever, when on their face they're stupid and not clever. Dark matter? That's a clever solution? Jeez.
A clear, intuitive idea of what one of these things...
Bent geodesic? That explains what gravity is? Bent doesn't even mean anything in 3 dimensions, you know.
...mean, then you're not going to be clear about the other one either. So basically, energy is a really useful mathematical concept. Beyond that...
Alright, so it's just too silly. It's the most fundamental thing to understand about the physical universe, is the concept of movement. How things move, why things move, can't get more fundamental to understanding reality.
Its exact definition is quite difficult to pin down with just words without doing...
Yeah, I don't think it's all that hard, and you could write a pretty precise statement that it's really just about a mass moving. And as long as you understand forces are made out of little tiny masses, problem solved.
A lot of technical work. At the end of the day, it almost doesn't matter what energy is. What matters is how it...
So that's frightening, you know. When, like, again, it's the most fundamental aspect of reality is motion.
It changes and how it allows us to predict the behavior of our system.
Okay, let's understand their predictions suck. Okay, they don't prove any of them. They don't show them predicting right. Their 2-slit predictions are crap. You know, as I've shown. It's all crap. It's all hype and talk. We have proven, we have predicted. It is the most predictive theory in the history of mankind. Blah, 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 blah. They're predicting their own failure. That's it. I mean, it's a circular crap. They're predicting their wrong answer.
The basis for this is the law of conservation of energy and how energy transfers.
So there was absolutely no evidence of this, any conservation by any kind of reasoning that would connect force to matter. And the simple connection is electrons and protons don't move on their own. They have to collect force to move. All the problems of physics have now just been solved.
Okay. And with all of that being said, I'm going to finish up here. Thank you so much for watching. If you enjoyed the video, please do hit the thumbs up button and subscribe for more fun physics content.
I hate that whole idea, fun physics. I mean, it's just such an insult to intelligence. Eek.
I've recently designed some merch based on a quantum mechanical...
Yeah, it's pretty poor, frankly. I'm not dying to get one.
dice design. I had a lot of fun creating it. If you'd like to check it out, please head over to the store.
I mean, it's really kind of simple. You had fun doing something that simple, and I don't know, it's just, yeah. Skull and crossbones would make more sense. You know. Maybe put Einstein and Feynman's face, you know. Which one will win? You know, you roll the dice. Who wins, Feynman or Einstein? Silly verse versus rational verse. Except for his whole fucking bent space bullshit.
Tab of my channel, or click the link in the description below.
Okay, yes. Physicists need to be told all of this. Look, you can go to my... Oh, anyway.
Also, I have a Patreon page if you'd like to support me on there. A huge thanks to...
Right, it's really great because then you get to pay 2 different companies, you know, for almost no service. So instead of just paying 3% to PayPal, you get to pay another 3% to Patreon. Or 5, I don't know how much they charge.
All of my Giga patrons, as well as all of my other patrons, and thank you so much for...
Oh, fuck. People suck. Ugh.
Watching. I will see you very soon.
It's just very disappointing that this is the mush that intelligent people waste their neurons on. But anyway, alright, so enough of a video. So in future I do plan on doing some of these videos as live videos. So just be aware, if you're a non-subscriber, you won't get notices and you won't see them on the channel video page. You have to go to the live page to see them. So just letting you know there is a bit of an inconvenience because YouTube sucks. Alright, so I think that's it. I was going to do a review, but to hell with it. I'm tired of the website videos. So there are videos on the website, alright, draftphysics.com. You can also see some of those videos on debatephysics.com. Or you can go to the YouTube channel Draft Science, alright, and you can either look in the video column or you can look in the live column for the recent videos. Shit, I can't believe I just I just did an explain video, and I hate the whole idea that I have to explain these tiny little functions, but yeah, you really do. Alright, so anyway, till the next time and such, and so forth and whatnot. Yeah, I think that's really enough. Yeah, we'll get rid of that, and then we'll get rid of me. Alright, so this has been at draftphysics.com video presentation. Till the next time and such.